Hey everyone, and welcome to Lesson 3 of our Explainer. Let's jump right in. Picture this. You open up a job board today, and right away, you see a posting screaming REST API experience required. You scroll down a bit, and the next one says GraphQL preferred. Keep scrolling, and another one demands gRPC microservices experience. 3 job postings, 3 completely different API styles. And honestly, if you only know one of them, you're already behind. A lot of tutorials out there just teach you one single API style, kind of treating it like it's the only one that actually matters. But out in the real world, choosing the wrong API architecture is this massive technical debt trap that literally costs companies months of engineering time to undo. So today, we're going to fix that and look at the whole picture. Here is our agenda for today. We are evaluating 5 distinct API architectures: REST, SOAP, GraphQL, gRPC, and WebSockets. Let's start with number 1, REST. Think of this as your everyday bicycle. So REST stands for Representational State Transfer. It was defined way back in the year 2000, and it is hands down the dominant API style in the world today. The core concept you need to know here is that absolutely everything is treated as a distinct resource. A user? That's a resource. An order? Resource. A product? You guessed it, a resource. And you access or manipulate these resources through standard, completely predictable URLs. The reason REST is the everyday bicycle is because it perfectly leverages existing web infrastructure. It relies entirely on standard HTTP methods that we all know: get, post, put, delete. It's also completely stateless. That just means every single request contains all the information the server needs to process it, right then and there, with zero memory of past requests. Plus, it primarily formats and exchanges data as JSON, which ensures universal compatibility across virtually any platform. But here is where we hit a snag. In the real world, when you send a GET request for a user ID, REST reliably returns the full JSON object. The catch? You get all the data. Let's say you literally only needed the user's name to display on a screen. Well, too bad. You are also downloading their email, their security role, and their entire account history. It's universally compatible for sure, but it can be a pretty blunt instrument. Keep that overfetching problem in the back of your mind because it leads us perfectly into our later styles. Moving on to number 2, SOAP. Think of this one as the enterprise train. SOAP stands for Simple Object Access Protocol. It actually emerged in the late 1990s and quickly became the absolute gold standard for enterprise software. Now, unlike REST, which usually relies on lightweight JSON, SOAP relies entirely on XML for both its requests and its responses. It is highly structured. It does not leave any room for ambiguity whatsoever. So you might be wondering, why on earth do we still use it? Well, it exists specifically for regulated industries that require strict, unforgiving data validation. It uses what's called a WSDL file, that's Web Services Description Language, to define a rigid, locked-down contract between systems. If a request deviates even slightly from that contract, it is rejected outright, no exceptions. SOAP also comes packed with built-in error handling and WS security for intense enterprise-grade encryption. If you ever work in banking, insurance, or healthcare, trust me, you're going to encounter the SOAP train. Just look at what this actually looks like in practice. A SOAP request meticulously wraps your query inside this massive XML envelope. It demands a header and a body, all defined by incredibly strict XML tags. This absolutely ensures adherence to the schema, which is great, but the trade-off is that it's heavily verbose. You're eating up a lot of bandwidth just to ask for a very simple string of data. Okay, let's shift gears. Number 3, GraphQL. This is our sports car. With GraphQL, the entire dynamic completely flips. Instead of the server acting as the boss and deciding what data comes back, the client is entirely in control of the data shape. The client explicitly specifies the exact fields it wants, and it gets all of it precisely as requested from a single endpoint. This was actually invented by Meta back when they were just Facebook to solve a very specific problem they were facing: overfetching. Remember when we talked about REST returning a massive, bulky user object when you just needed a name? That wastes precious mobile bandwidth. GraphQL solves this beautifully through client-defined schemas that are sent to just one single post endpoint. Because you only pull down exactly what you ask for, it is insanely efficient for mobile applications where every single kilobyte of data matters. Here is the massive advantage for developers. On the left side here, getting a user, their posts, and the comments on those posts requires 3 completely separate REST API calls. On the right, one single GraphQL query fetches all of that data, perfectly formatted together. It's incredibly powerful. Just keep in mind, giving the client this much power definitely shifts a lot of the complexity burden directly onto your server. Now for pure speed. Number 4, gRPC, the specialized racing car. gRPC stands for Google Remote Procedure Call. This is an architecture that actively, deliberately sacrifices human readability entirely, all to achieve maximum processing speed. It essentially asks the question, what if we literally didn't care if developers could easily read the API payloads as long as the machines could process them instantly? It achieves this blazing, unmatched speed by utilizing protobuffers, or protobuf for short. By serializing data into a tiny, tightly packed binary format, it shrinks payloads down to just a fraction of JSON's size. You throw that data over an HTTP/2 connection with concurrent data streams, govern the whole thing by strict .proto files, and you end up with unparalleled machine-to-machine speed. To put that into perspective, here's the tangible difference. A standard user payload that takes up 150 bytes in JSON shrinks down to just 40 bytes in protobuf. When you are a massive company like Netflix or Uber, and you're passing millions of messages between your internal microservices every single second, drastically cutting that latency is a total game changer. It's amazing for server-to-server communication, but, as you might guess, it's pretty terrible for web browsers. That's why it's kept mostly as an internal tool. Finally, number 5, WebSockets. Think of this one as your walkie-talkie. Every single API style we've looked at up to this point strictly follows a request-response model. The client asks, the server answers, and boom, the connection closes. WebSockets throw that out the window. They establish a persistent bidirectional channel. That means the connection stays open indefinitely and data can just flow freely in either direction at any time. This completely breaks the traditional HTTP model, and it exists specifically for real-time applications. Imagine you're building a live chat app or a dashboard showing live ticking stock prices. With standard HTTP, the client has to constantly keep asking the server, any updates? Any updates? With WebSockets, the initial connection upgrades from HTTP to a raw TCP channel. From that exact moment on, the server can instantly push data directly to the client without ever being prompted. Look at the efficiency difference here when you have real-time needs. HTTP polling forces your server to constantly open, negotiate, and close connections over and over again. A WebSocket upgrades just once, leaving a free-flowing stream open. But a quick warning, keeping those connections open consumes server memory. So only deploy WebSockets when real-time, instantaneous updates are absolutely mandatory. Okay, let's bring this all together. This trade-off matrix summarizes our 5 architectural styles, letting you evaluate format, performance, and best use cases at a single glance. REST, that's your everyday default JSON-based choice for public APIs. SOAP gives you XML-based, rigid security for those strict enterprise systems. GraphQL offers you flexible, client-defined JSON for complex front ends. gRPC delivers maximum binary performance for internal microservices. And WebSockets give you those persistent connections for real-time features. At the end of the day, there is no single best API. There is only the right tool for your specific engineering requirements. Choosing the wrong API style creates massive technical debt. Seriously, if you try to use WebSockets for everything, your servers are going to crash. If you force GraphQL where a simple REST GET request would do the job perfectly, you're just over-engineering. You have to evaluate your needs across data complexity, performance, and real-time requirements. But the good news is, you now have the framework to confidently deploy REST, SOAP, GraphQL, gRPC, or WebSockets based on precise engineering trade-offs. Here is a final provocative thought to leave you with today. Now that you know the specific superpowers and the limitations of each of these 5 architectures, which one do you think is quietly creating hidden bottlenecks in the apps you use every single day? Thanks for